Okay, if you don't have any question, then let's go ahead and start this example. Okay, so here we have a ball, okay, which is dropped from a height of 100 meter. At a time t, the height of the ball from the ground is given by this function. So we have this function f of t equals to negative 4.9 t square plus 100, and this function give us the height of the ball, okay, in t second. Like if we want to find what is the height of a ball when 0 second, what would be the height? It's a 100, right? You substitute t equals to 0, and if we substitute t equals to 0, we get 100. So we have a ball at 100 feet. Okay, we drop a ball. Now, as the time changes, the height also changes. Okay, and this height for a ball is given by this function. So we have a function f here. Okay, and our t is the domain. Okay, and f of t is the output. Now let's talk about the domain. T is a domain. So what kind of t what kind of domain we will have for this function? Can we have like any number as a domain for this function? Okay. So what is our t? We have our t very specific domain. Our t is a time, and our time cannot be negative, right? So we can't have a negative 1 second. So we can have a 0. That's a starting point. Okay, so we can have like a starting point which is a t equals to 0. So our domain for this function is any number equals to 0 or greater than 0. Okay, but if we just take this function as a very general function, this is a quadratic function, and yes, you are right, from negative infinity to positive infinity is the domain. But here this function is very specific. This is a height function. Okay, we use this function to find the height of a function. Okay, now in number A, we are asked to find the average rate of change on the interval 1, 3. So it means when your time is equals to 1 and when your time is equals to 3. So we have to find what is the change in the height. Okay, so our average rate of change is given by, so average rate of change is given by, so we have f of x2 minus f of x1 divided by x1 minus x2 minus x1, x2 minus x1. Now here, so let's call our 1 is a x1 and 3 as a x2. Okay, so our x1 is 1, x2 is 3. Now we find f of x2, we find f of x1, and we substitute the remaining. Okay, now let's substitute our x1 and x2 in this expression. So we have f of our x2 is 3 minus f of 1 divided by 3 minus 1. Now what is our f of 3? How do we find f of 3? So how do we find f of 3? So let me do here on side. Okay, so f of 3 is, you substitute 3 for every t in our function. Okay, so our function is, so our function f of t is 4.9 t square plus 100. This is our function. Now we are trying to find f of 3, and what do? We replace every t in this function by 3. So we have negative 4.9 times 3 square plus 100. Okay, now can anyone help me with this here? So what is this equals to? Negative 44.1. Okay, now similarly let's find, we need to find f of 1. Okay, so f of 1, now you replace your t by 1. So we have negative 4.9 times 1 plus 100, and this is 95.1. So yes, it's gonna be a, so do we get a negative for f of 3?
We have to add the 100, don't we?
Yeah.
Yeah, we have, oh, okay, oh, yeah. So, including, okay, so if we add 100, so we get positive. So, okay, so let me get a final answer. So, what is negative 4.9 times 3 square plus 100? 55.9. Okay, we have 55.9 f of 3 and f of 1 is 95.1. Now, let's substitute this. So, our f of 3 is 55.9 minus our f of 1 is 95.1 divided by 2. And what is this equals to? Is it, so final answer is negative 19.6. Yes, okay. Now, what is the, so if we talk about the unit, so what is f of x2? What unit does this x2 have? So what is this 55.9? Is this a time? Is it a meter? Or what is this? 55.9. Is that a time? Height, that is a height. Okay, let's call height. Our height is, okay, it doesn't mention. Let's call it 55.9 meter. Okay, because this is our height and 95.1 is also a height. Okay, our this 3 is a second, 1 is a second. Okay, our input is a time, but once we input our time, we get the height, and our height is meter. So we have our average rate of change is negative 19.6. We have a meter in the numerator, right, and second in the denominator. So it's a meter per second. Now, what does here negative represent? Why we are getting a negative?
How much it drops each second?
Okay, now since the ball is dropping, the height is decreasing, right? So since we are dropping a ball, so here the negative represents that the ball is falling down. Okay, it does mention in the problem that the ball is dropped. Okay, but if you have negative here, this negative tells us that the ball is dropping down. Okay, and when we throw a ball upward, we're gonna get the positive average rate of change, because when we throw up, the height changes, height increases. Okay, so here the height decreases continuously. Okay, the change is in negative, it means it's dropping down. Okay, so this is about average rate of change. Now next, let's find the difference quotient for this function. Okay, the difference quotient is given by, so for number B, so our difference quotient is f of a plus h minus f of a divided by h. So this is our difference quotient, and this difference quotient has meaning. Okay, so when you just take upper level math courses, this difference quotient, we call this derivative. If you have heard it, this expression is the derivative. Okay, so here we will try to find the value. We'll try to simplify this expression. Okay, we are not going to study what is its meaning. So this is the difference quotient. So every time if you are asked to find difference quotient, this is what we're gonna find. Okay, to find this expression, we need to know what is f of a plus h, and we need to know what is f of a. Now let's find these two expressions. Our function f is given as f of t is negative 4.9. So negative 4.9 t square plus 100. So this is our function. We are trying to find f of a plus h. Now how do we find f of a plus h?
Subtract e from a.
To find h is b minus a, but here we are trying to find f of a plus h. Okay, now here if we compare here, so we have f as it is. Now for t we have a plus h, right? So what are you gonna do? We're gonna substitute t equals to a plus h. Okay, so it's the same thing. Your input is a plus h. The only difference here is that your input is a plus h, and you are finding the output when your input is a plus h. So you substitute a plus h for every t. So we have negative 4.9, and your t is a plus h square plus 100. Does anyone have question here? You have an input, you are finding the output, and the process is same. You substitute your input a plus h for every t. Okay. Now let's find f of a. Now what would be f of a? Your input is a now. You just compare with this expression to find the input. Okay. So for t we have a. It means a is our input, and for every t we substitute a. So we have negative 4.9. For t we have a squared plus 100. So this is our f of a. Now we substitute our f of a plus h, f of a in this difference quotient, and we simplify. Okay, let's go ahead and do that. So here, so our f of a plus h is negative 4.9 a plus h squared plus 100. Okay, so we have this negative, so we have negative. F of a is negative 4.9 a squared plus 100. We have a two terms, so we need to have a parenthesis here, divided by h. Any question up to here? Now let's simplify our numerator and we get the final answer. So we have negative 4.9. Now how do we find a plus h square? Okay, so this is not equals to a square plus h square. Okay, so a plus h square is not a square plus h square, but a plus h square is same as a plus h times a plus h. Okay, do not write a square plus h square. Okay, that's not true. Plus 100 negative, so we have negative. Now we have the parenthesis, and what does the negative do? We distribute negative for each term. Okay, so you multiply negative and each term. So negative times negative 4.9 a square, that is positive 4.9 a square. Okay, and we have negative times positive 100, that is negative 100, divided by h. Now here we can cancel positive 100 and negative 100. So we have negative 4.9. So let's use FOIL here. So you use the FOIL, multiply the first term. So a times a, we have a square, multiply the inside term or the outside term, a times h, positive ah, multiply the inside term, h times a, we have ha or ah is the same thing. Okay, and we multiply the last term, h times h, so we get h square. Okay, and since we have more than two terms, so we're gonna have the parenthesis here. Okay, so we have like 4 terms, so it should be inside parenthesis, and we have the product here, positive 4.9 a square divided by h. We are almost done. Now we distribute negative 4.9. Okay, so we have negative 4.9 times a square, that is negative 4.9 a square, negative 4.9 times positive ah, that is negative 4.9 ah, negative 4.9 times as, that is negative 4.9 ah, negative 4.9 times h square, negative 4.9 h square, positive 4.9 a square divided by h. Now here negative 4.9 a square and positive 4.9 a square cancel, so we do have a like term here. So negative 4.9 ah and negative 4.9 ah is a like terms, so let's add these two terms, and this is equals to, so negative, is it 9.8 h negative 4.9 h square divided by h. Any question up to here? Now we have one more thing. What is that? What can we do in the numerator? If we compare two terms, what common thing we see? H is the common, right? So we can factor out h in the numerator. So let's factor out h. So once you factor out h, we're going to have negative 9.8, negative 4.9h divided by h.
This is not a name, the 9.8.
I'm sorry?
The 9.8 is AH. It's AH.
Oh yeah, thank you. So we have 9.8a. Okay. So we have a here, so we're gonna have a here. Okay, now we can cancel this h and this h here. You can't cancel here, okay? Like at this point, you can't cancel your h and the h in the numerator. When you cancel in the numerator and denominator, it has to be in a factor form. Factor form means like here, so we have h times this expression. It means we have in a product form, then only we can cancel. If we have an addition, like here we have a minus. If you have a plus, then you can't cancel. It has to be in a product form. Okay. Now the remaining is our final answer. So negative 9.8a plus, negative 4.9h is the final expression. Negative 4.9h. So this is the final expression. And like this has a meaning. So we use this expression to find the speed of a ball. Okay, like the ball has been dropped, right? And this expression gives us the speed. So this is the derivative. Okay, we don't do it here, we only simplify here. So every time if you are asked to find the difference quotient, so you are finding this expression f of a plus h minus f of a divided by h. Okay, this is what you have to find every time. Okay, so let me know if you have any question from this section or this specific example, section 2.6. Question from your homework. Okay, I think I might need to update the deadline for your homework, right? So I will just change that. Okay, so let's go ahead and just do section 2.7. The 2.7 is it's not difficult, it's the easy one. Now here let's consider we have a two function. So we have a function f, we have a function g, okay, and for the both function our domain is x. X is the domain for f function, g function. Okay, now we will try to find the sum of these two functions, difference of these two functions, product and the quotient. Okay, so sum of these two functions. So if we want to find f plus g function, then you are adding two function. So you have a two function. If you want to find the sum of two function, you add those two function. Okay, if you want to find the difference of these two function, then you are finding the difference of the function. So f of x minus g of x. Okay, and f times g function is f function f of x times g of x. Okay, if you want to find f over g function, then it is equals to f of x function divided by g of x function. You have a two different function, both function must have a same domain, and you want to find a f plus g function, then you are adding f function and g function together. If you want to find a difference, you're going to find the difference of two function. Okay, if you want to find f g function, then you are multiplying these two functions. Now let's do an example, it will be more clear here. Okay, so here we have our f function is 2 over x minus 4, our g function is 3x minus 1, and we are asked to find f plus g function. So in between f and g we have a plus, so we are adding these two function. So here, so f plus g of x is f function plus g function. So you are adding two function. Okay, so here we have a plus, so we have a f plus g. So you're gonna add f of x and g of x. So it's not we are distributing here. It looks like you distribute x, okay, but it's not the distribution here we did, okay. So f plus is a new function. So we are given f function, we are given g function, and we are trying to find a new function, and our new function is f plus g new function. And this is you are adding f function and a g function. Now let's add these two functions. So what is f of x given to us? F of x is 2 over x minus 4 plus what is g of x? 3x minus 1. Now here I don't want you to simplify. If you don't have a denominator, then just go ahead for simplifying. Look for the like terms, add the like terms. Okay, now here we don't have any like terms. Okay, so this is our final answer. So this is the final answer. Okay, now let's find again number b. So let me write down here number b. So we need to find f minus g of x. Now in between f and g, what we have? Minus, right? So you find the difference. So f minus g of x is same as f of x minus g of x. So if you have a plus, you're going to add two functions. If you have a minus, you're going to subtract two functions. Now let's substitute our f of x. F of x is 2 over x minus 4. We have minus, and when you have minus, you have to be extra careful, okay? Now our g of x has a two terms. It means we need to have a parenthesis here. So parenthesis 3x minus 1. If you have a positive, you don't need parenthesis, okay? It remains the same. But if you have negative, make sure to have the parenthesis. Now let's distribute our negative, and we have the final answer. So we have 2 over x minus 4. So negative times 3x, negative 3x, negative times negative 1, positive 1. And this is the final answer. Okay, nothing to simplify from here. Now, can you all find f g function? Can you all do number C? So in number C, let me know if you have any question in number A and number B, okay? Now in number C, we are asked to find f times g, fg function, and f times we have a product there. So f times g function is equals to f function f of x times g of x. So your fg function is f of x times g of x. Now you substitute your f of x. Our f of x is 2 over x minus 4 times g of x is 3x minus 1. So make sure to have the parenthesis. And this is your, you can just write this numerator together. Okay, so 2 times, so we have 2 times 3x minus 1 divided by x minus 4. Yeah, you can just write up to here as your final answer. You are multiplying two functions if you want f g function. If you want f plus g, you are adding. If you want f minus g, you are subtracting. Okay, now the last one we have f over g. So here we have f divided by g. So we divide f function by g function. So this is f of x in the numerator divided by g of x in the denominator. Now let's substitute. Our f of x is 2 over x minus 4 divided by g of x is 3x minus 1. Now let's simplify here. Okay, how do we just rewrite? So here we have this as our numerator. So this is our numerator, okay? So we have like a fraction in the numerator. So this is a complex fraction, okay? And here in the denominator, so this is the denominator, okay? So can we rewrite this as a 3x minus 1 over 1? Is it still same thing? So 3x minus 1 has a denominator 1, okay? Now, if you want to simplify a complex fraction, complex means you have a fraction in the numerator. You have a fraction in the denominator, like here. So this is our numerator, okay? So this is our denominator. And if we want to simplify this complex, so what we do here is that we rewrite our numerator as it is. So this is our numerator, we rewrite our numerator as it is. So let me rewrite 2 over x minus 4. Okay, so we rewrite our numerator as it is, and this division, so we have this division. Okay, so we replace this division by product. Okay, and we just, this is, and the numerator and the denominator, so this is our denominator, we write down the reciprocal of denominator. Reciprocal means you flip numerator and denominator, you switch. Okay, so we have 1 over 3x minus 1. So if you have a complex, you write down your numerator as it is, then multiply by the reciprocal of the denominator. Okay, see, the numerator has been same, 2 over x minus 4, 2 over x minus 4. Okay, and for the division we have a product, and this is the denominator, and denominator has been, we write down the reciprocal. It means you switch these two, numerator and denominator, one goes up, okay, and this numerator goes down. Now we can do one more here. Now we have the product of two fraction, so 2 times 1, that is 2, divided by x minus 4 times 3x minus 1, and you can have up to here as your, okay, this can be your final answer. Okay, you don't need to just find the product here, but yeah. Okay, I know I went pretty fast here, but are you all feeling comfortable with this? If you have a plus, you add. If you have a minus, f minus, then you find the difference. Okay, if you have f times g, you find the product. Everything is given, you just substitute. Okay, if you are asked to find the quotient, you have the division. Okay, okay, now if so, let's go to our next example. So here, okay, so here we have the Global X Corporation has a revenue. Okay, so we have this expression R of t. This is the expression that gives us the revenue for the corporation. Okay, where t is the number of year. Okay, or t is the number of years. T is number of years since 2010. Okay, RT is in millions of dollars. Now let's see what does it mean here. So we have a Global X Corporation, okay, and its revenue is given by this expression, 40 plus 2t. T is the number of years since 2010. Now, if that is the case, what would be the R of t in 2013? How do we find that? 46. Okay. Now, for 2013, what is our t? 3, right? T is the number of years since 2010. So you substitute t equals to 3 in your RT function. Okay, so we have 40 plus 2 times 3, that is 6, 46. And what is our RT? RT is in millions dollar. So can you tell me the revenue in 2013? 46 millions dollar. Okay. Similarly, so what is the revenue in 2010? 40 million. Do you all agree? For 2010, t is 0, right? Because we define our t as a number of years since 2010. And if we are taking a same, then it's a t equals to 0. So we have 40 millions of dollars as our revenue, okay, for this corporation. Okay, now its operating cost. So we have a cost function. Operating cost is modeled by this function. So we have C of t. This is the operating cost function. This gives us the cost of operating function, and t is the number of years since 2010. Now what is the cost? And CT is, okay, cost function is also in millions of dollars. Okay, so what is the cost in 2010? What is the cost of operating this in 2010? 35 millions dollar, right? Okay, so similarly we can find the cost for the remaining year, right? So if we want for 2000, okay, let's take 2012. What would be the cost function for 2012? Our t is 2, right? So we substitute t equals to 2. 35 plus 1.6 times 2. 1.6 times 2 is 3.2. plus 35 is 38.2. So we have like $38.2 million as a cost for 2012. Okay, so this is how we can just find or we can just predict the future cost or the revenue. Now, from here, now like if you are asked to estimate the revenue for 2030, can we estimate the revenue for the upcoming like of the 2030? So we can find, right? So this function, it helps us to estimate, okay? It may not be exactly correct, but we can estimate. Okay, we can make it, and similarly we can find what will be the cost in 2030. Okay, now here we are asked to find the profit function. So we need to find the profit function for Global X Corporation. We have the revenue, we have the cost. Now what is profit? How do we find the profit?
Do you subtract operating minus revenue?
Okay, we subtract the
Operating minus revenue?
operating minus revenue or revenue minus cost function, right? Okay, operating. So our profit function, okay, our P of T is a profit function, and profit function is our revenue function, our revenue R of T minus our cost C of T. Do you have any question on this expression? You have the revenue, okay, and you have the cost, and the profit is revenue minus cost. So let's substitute. Our revenue is 40 plus 2t minus, we have a minus, so make sure to have the C of T inside the parenthesis, 35 plus 1.6t. Now let's simplify this. So we have 40 plus 2t minus 35 minus time minus positive 1.6t, that is minus 1.6t. So 40 minus 35, these are the like terms. So we have 5, 2t minus 1.6t, that is positive 0.4t. So this is our profit function. That's what we want here. So this function, this expression give us the profit. Now let's find the profit for 2013. So what will be the profit for 2013? So t is the number of years since 2010. Okay, it's the same thing. So we substitute t equals to 3, right? So we have 5 plus 0.4 times 3. 0.4 times 3 is 1.2 plus 5 is $6.2 million. So that is the profit. So this function gives us the profit for this case. Does anyone have question? So everything is given. We just find the difference here. Okay. Sometime like in the similar case, so if you are asked to find, so you are, suppose you are given a profit, you are given a cost, how do you find the revenue? You are given a profit, you are given a cost. Now how do we find the revenue? Yes, you're going to add the cost and profit together, you get the revenue. Okay, so that will be the case. You will be adding the functions. Okay, now let me know if you have any question up to here. If not, we're gonna talk about a new function, composition function. Does anyone have a question? Okay, so before I go to the definition, let me go back to our very beginning of a function. So let's consider we have a set x. So let's say we have a set x, we have a set y. Okay, and we have a function g. Let's call we have a function g from set x to set y. Okay, and we have another function set g, and we have a function f from y to g. So our g is a function from set x to y, f is a function from y to g. Okay, so we have A, B, C here, 1, 2, 4, 5. Okay, so A associates with 1 here, B has a correspondence with 2, and C corresponds with 2 here. Now, is G a function or not at first? Is G a function or not? Yes, right. So for G, what is the domain here? Which set is the domain for G function? X is, right, the very first set. So this is the domain for function G. Just let me write domain for G. And what about set Y? Set Y is a range for function G, right? So the range for function G. Your input is ABC. You input your A, you get output 1. You input B, you get output 2. So 1, 2 are the range and ABC are the domain for function G. Now let's define our function F. So function F, 1 corresponds to 4 and 2 corresponds to 5. So if we are talking about function F alone, what is the domain for function F? Which set is the domain for the function F? Set Y, right? So our set Y is a domain for function F. And what is the range for function F? G, right? Okay, the range is G, 4, 5. Let me know if you have any questions. So we define a two function here. Okay, we have a function G from set X to Y. We have a function F from Y to Z. Now let's define a new function from set X to Y. So let's define a new function from set X to Y. Okay, and this new function we called F composite. Okay, this is a composite G. We define a new function here, and new function is from set X to set G. So we have new function. Okay, we have new function F composite G. This is F composite G. Just let me write. So this is F composite. Okay, composite. So we just use this open circle for the composite G. So we have F composite G as a new function. And this new function is from set X to set G. Now, is this a function or not? Now, before that, okay, what would be the domain for this F composite G function? Set of X, right? The very first set is the domain. So our set X is the domain for F composite G. And what will be the range for F composite G function? G, okay. So G is the range of F composite G function. Okay. Now let's check whether this is a function or not. Okay, so when your input is A, what is the output in this composite function? What output do we get? 4, right? Okay, so here, so A, this is the input. So when you input A, we get 1 here, and from 1 we get 4. So when you have your input A, we get output 4. And when we have input B, what is the output we get here? So we have 5. And when the input is C, what output do we get? 5. Now, is it a function or not? So we have every input ABC. They have exactly one output. That's what we want to be a function. So this is a function here. So here F composite G is a function. Okay, is a function from set X to set G. Okay. Now, so here let's find. Okay. Let me go by name. Okay, we have a EV, right? So EV, can you tell me what is f of 1 equals to from this mapping diagram? Can you tell me what is f of 1 equals to 4, right? Okay, that's right. So our function is f. So you are looking this function. Our input is 1. So this is the input. And when you input 1, you will get our 4 as the output. That's good. Okay. Okay, we don't have Peter. Mason. Okay, so what is G of C equals to?
5.
G of C. 2. Okay. So our function is G. So we're going to see here. This is our G function. Input is C. So we get output 2. That's right. Okay. Colton, So what is f composite g of p? So what is f composite g of b? 5. Okay, let's find out. So here, this is our f composite g function. Okay, f composite g function is from set x to set g. So our input is b. So this is the input. And if we follow, so 5 is the output. That's right. So 5. Okay. Okay, Michael. So what is f composite g of a? What is f composite g of a?
4.
That's right. Okay. So similarly, we can find the remaining. Okay. Now, okay. Do you have any question here? Now we go back to our definition here. So our definition is, now in general, we don't do mapping diagram every time. Okay. Because our function is not only mapping diagram. We get an equation. We get a set of order pair. Okay. So in general, our f composite g function, okay, our f composite g function, so this, we have a f, this is composite, okay, make sure you should know how to read. F composite g of x is f of g of x, okay. So every time, if you are asked to find f composite g of x is, you write down f of this x, okay, of g of x. Okay, so this is f of g of x, f of g of x. So this is the definition. So one more thing here. So what common thing? So if we compare the domain of g function and domain of composite function, what can we say? So if we compare the domain of g function and domain of f composite g, what similarity we have here? So what is the domain of g? So our domain of g, so in this example, so set x is the domain of g, right? And same set is the domain for f composite g. So f composite g and g has the same domain. Similarly, so here the range of f composite g and the range of this f function is same. Okay. So okay, I need to correct here. So this is a range of not g. Okay. So I'm sorry. So this is not range of g. This is range of f. So the range of f composite g and range of f is same. Okay. And the range of g and the domain of f, it is the same. Okay, now in the similar way, can we define what is g composite f equals to from our definition? So let me write. Our definition is, when we have f composite g of x, its definition is f of g of x. Now if this is the case, what would be g composite of f of x equals to? So you write down g at first, of f of x. Okay. Now let's use this definition for our next example. So we have this example. We have our f of s. This is a function, s squared plus 1. And we have a g of s, which is negative 2s. If we compare these two functions, what is one common thing that you can see? So what is the common thing that both f and g function has?
Same domain.
Same domain, that's right. So here, see, the f has a domain s, g has a domain s. Okay, so the domain is same here. Now we need to find f composite g of s, and we need to find the domain of this function. Okay, so let's write down our definition. We are trying to find f composite g of s. So this is from the definition. So you write down f parenthesis g of s. So you just replace your composite by parenthesis. You get the definition. See, if you compare this definition and f composite g, the only difference is that instead of composite, you add parenthesis and you get the definition. Okay, it's not difficult to know this definition. Now, the remaining is substitution. Once you know the definition, now it's going to be easy here. So, at first, we have f as it is, okay? Now, what do we know about our g of s? Do we know anything about our g of s? What is g of s equals to? Negative 2s. So, you substitute negative 2s for g of s. So, you have f as it is, and for g of s, you substitute negative 2s. Okay, now what are we trying to find by f of negative 2s? How do we find f of negative 2s?
Plug it into the first expression.
Okay, so this is f function, right? So this is f function, and we do have f function as a s square plus 1, and this is our input. Whatever you have inside the parenthesis is the input. So you substitute negative 2s for every s in your f function. Okay, so we're gonna substitute negative 2s for every s in f function. So our f function is s square plus 1. So for s, you're gonna substitute negative 2s. So we have negative 2s, and we have a square, so more than one term. So we're gonna have parentheses plus 1. And once you substitute, you are not writing f anymore. Okay, like once you substitute your g of s equals to negative 2x, there is no g function. Okay, g means once you substitute, there is no more g. In the similar way, you substitute negative 2s for f function, and once you substitute, there is no more f. F is gone. Okay, we get the output. Okay, now let's simplify this. So we have, so this square is for every term that we have inside this, right? And here, okay, let's find one difference here. Before this one, so if we have something like negative 2s, so let's find negative 2 plus s squared. What difference do we have in between these two? Yes, so here we have a 2 times s, right? So here we have a positive. Now let's find what's difference when we simplify these two. So here, so if you have a product, okay, then if you have a product, this exponent is for each of these. This square is for negative, this square is for 2 and for s. So if we simplify, we get negative square is positive, 2 square is 4, s square is s square, and we have plus 1. But if we have this, okay, this expression is not negative 2 square 4 plus s square. This is wrong, okay, this is absolutely wrong. We can't do this. So here we have to rewrite this. Negative 2 plus s square is negative 2 plus s times negative 2 plus s. We use FOIL and we simplify. Okay, if you have a product, then only your exponent, you can distribute exponent. Otherwise, you can't. Okay, now this is the final answer. Okay, so this is our f composite g function. So this is our f composite g function. Now for this function, what represents the domain? What is the name of function here? So the name of function is f composite g. Okay, what is the domain here? S. That's right. So this s represents the domain. Now let's find what is that domain. Now finding domain means we are looking for what kind of number we can have for s so that we get the output. And your option is from negative infinity to positive infinity. Now, what kind of number from a real number we can have for this s? Can we choose any number and we get the output? It doesn't matter, right? So for this case, It doesn't matter what number you choose, we always end up getting output. So the domain for this function is from negative infinity to positive infinity. So the domain, so let me write f composite g, domain of f composite g is equals to from negative infinity to positive infinity. So it means your s, it can be any number, okay, any real number. Okay, let's do this much for today. Okay, the remaining